Hey everyone, I'm Kshitij. Welcome to another episode of Tractable. I'm the co-founder and CTO in Orb, and today I have Neil Patel joining me, who's the co-founder and CEO of Axiom. Axiom is a new type of logging tool built with modern cloud primitives, meaning it's serverless and works really well, even at massive scale. Axiom is used by a ton of great companies like Prisma, M1 Finance, and Cal.com. I'm super into the logging space, and I think there's going to be a bunch of technical stuff to talk about, so we're really excited to have you here, Neil.
Hey, great to be on. Thanks for having me.
Of course. Let's get into it. I want to give you a chance to talk a little bit about the general product shape of Axiom. So why don't you give us and the audience kind of an explanation of what Axiom is and what the kind of use cases it serves?
Yeah, so Axiom is essentially a store for 100% of your event data across many different needs. So I think you hit on logging. Observability is what we are known for. More and more security, product analytics, and other insights which you'd like to gain across these kinds of data is where we find a home. The reason for that is we've basically built a data store from scratch, which is, as you mentioned, using kind of cloud native technologies like serverless, object storage, etc. But really it's tuned specifically for events. And so that means any kind of key value pairing, which one of them has time. Instead of worrying about, for instance, data that would be correct for, let's say, Snowflake or Postgres or anything like that, this is hyper specialized for events. And therefore we can do some really neat stuff and allow some cool use cases on top. So yeah, one of them is being able to do things that you would generally do in a logging tool or event management tool in terms of querying, being able to manipulate those during queries. So schema on read, those kinds of things, dashboarding, monitoring, etc. And then also with that, we also have the ability to do the pipelining side. So actually processing of events and having them output somewhere else. And so it's mixing those two things together in one place.
Yeah, that makes sense. And when I go to your website, Axiom, the first thing I see on the homepage is this idea of stop sampling, observe every event, right? So talk a little bit about that product philosophy and why that's so important to, I'm assuming, especially your target audience, but maybe more broadly, like that's almost a reactionary message. So speak a little to that.
I think we're still the only company that actually asks people to stop sampling instead of giving all the different ways you can do sampling. Look, for us, we always felt, even in the products we built previously, anytime you were losing data, and especially when it was to do with cost of all reasons, you were putting yourself in a position where you essentially have like Swiss cheese of history, essentially, like tons of holes, tons of gaps. And we always felt like you'd want to lean more heavily onto the ability to do analytics, insights, those kinds of things, forecasting, more of the ML side, etc. And this is before the kind of AI stuff took off, but I'm just talking about stuff that was available, but maybe not easy for people to use or developers to engage with. We felt like coming at it with a angle where essentially, if you keep everything, you have history. If history is there, you can learn from it and do something interesting in the future. And so we went about just trying to solve that problem and probably hit every issue on the way there. But we got to somewhere where we can actually turn around and say, hey, stop sampling, and it's not going to completely bankrupt you.
Yeah, that makes a lot of sense. One thing I'm wondering about is this logging and events and metrics. There's a lot of different terms here, and these products are built for a lot of different audiences. My background worked at Asana. Asana made heavy use of Datadog and had some logging and metrics set up there, but also made heavy use of Interana, which I believe maybe is now rebranded, but was, I believe, originally inspired by Scuba. And talk a little bit about who Axiom is built for. Is it the engineer that is piping request logs? Is it someone in BizOps or even a different audience? How do you think about that?
So that's a great question. I think the way we see it is, and this may be because we have databases in mind too much, is essentially those are specializations on top of the actual store. And so what happens is when you're a startup and you're sending data to Segment and then Mixpanel, whether you're sending data to Datadog, or whether you're generating data from, let's say, Zendesk or something, or Plane or etc. The problem that you have is you're basically creating and then dispatching into silos. And those silos might be specialized on the actual data, but what you've done is essentially sent everything to there, and then you pay them monthly to lease back that data from them. And so
Right.
the thinking on our end is Axiom doesn't have to be the answer where the BizOps person comes in or a data scientist comes in and uses it. It's more in terms of, for those specializations, can you at least have one source of truth where
Yeah.
the ownership is with the organization that generated the event, and then there can be specializations on top which actually go and they solve a problem for you, right? And
Yeah.
so there's a bunch of startups who are building on top of Axiom at the moment, and I'm hoping for a summer release schedule so I can shout about them a little bit more. But essentially what they've decided is they want to offer that to their customers, where they're saying, hey, we're going to go solve this security problem or a finance problem or whatever, but we're going to actually hold your data in Axiom because you have direct access to it, and you may want to do something else with it.
That's really interesting. And I'm actually curious about the product thesis there. So to reflect that back at you, it sounds like Axiom's job is to be a really good source of truth, a really good data holder, right? And it sounds like what you're saying is it's not as important to you, maybe in the current phase of the company, to directly address all of the different workflow needs. You think that might be a better place to leverage integrations or partnerships. It sounds like the kind of core IP and the technical innovation of the company is in really fast access to this data and durable storage of the data. Is that right?
So that's one large part of it. And then the other side of it is what we call flows, which is essentially, if you think about the data store essentially bringing data at rest, essentially bringing it to rest, flows brings it back into motion again. And so if you're thinking about like the building blocks of any company who actually has an event store as its base, these are all the things you need to go and achieve, for instance, being able to build models or be able to export into the third party so that can do something, or even as simply to run long running reports and things like that. And so it's that mixture of storage and such with flows to like bring it back up into that motion piece and do something with it. And so it feels like more like for us where we're building a platform, and that platform has various kind of tooling, which then you can bring together. Now, as a user, you can bring it together for the things you're trying to solve. Absolutely. And that's obviously the first like customer and the first people that we want to make happy. But then there could be a security product that's trying to build the next gen SIM, and they're looking at Axiom and saying, well, you already speak events. And so why don't I just use you and focus on the actual, what the users would care about?
That's interesting. And I like that because it seems like a central part of that story is that Axiom is still directly accessible to you in this sort of really nice user interface,
Absolutely.
which is maybe is different than just selling a pure time series database, right? It's a
Yeah.
product, not a database. And of course, maybe the core underlying technology is a database, but it's not something where it's completely wrapped by another product, right? It's more like you
No.
plug it into a bunch of different layers.
Yeah. And that's how these partnerships, that's what they will show more clearly in exposing, because this hasn't, you can kind of do it with something like Snowflake, etc., but it hasn't really come to the masses in a way which actually is easy to understand and see where the value is. But we really think the value is every startup should actually have a complete history of everything that they've done, because that's going to be useful for the future and many reasons now as well. But it's also this idea where it's one writer, many readers, right? And like taking that philosophy and putting it onto this storage layer where we feel there's more happening and more kinds of tooling you use, which is actually using event data than there is the other kinds of data. And therefore, you're probably going to get more value out of this over time.
Yeah. So I want to back up for a second and just talk about the sort of data that people are putting into Axiom. And maybe even you can explain what the different steps you need to start using Axiom are, right? So how do you get data in? What sort of data does that typically look like? And then what can you do with it? You already touched on this a little bit, but I think that's good explanation to have? So then we can talk a little bit about the technical internals.
We have like various methods of ingest. And so some of them are like, you could classify them for a specific use case. So for instance, we support Elastic's bulk API. We support, other kind of NDJSON, those kinds of APIs where if you have a log shipper or an event shipper, because you're using Logstash or Cribble or something like that, you can just hook it up to Axiom and say, from now on, send everything there. And so the kind of data you'd be getting is from like Kubernetes, you'd be grabbing data from firewalls, you'd be getting application data, trace data, all those kinds of things can land inside of Axiom. Axiom doesn't know what it is. It just sees that it's essentially a JSON and it has a timestamp. And so that in the middle, it loses that knowledge of what's happening. So like when it comes in, we know, and when we do something within the UI, we know. But otherwise, in the middle, what the data store sees is just a whole bunch of key values. And essentially, those can be thousands and thousands of them. So super, very wide events. And essentially, the idea being is you emitted some kind of record and you want that to be as featureful as possible of all of the state of what was happening. And so, the kind of observability streams and logging streams are one of them. The other side is, of course, security data. So a lot of flow logs and things like that. But then also, syncing in every Stripe webhook that's existed for your system, for your company, that comes in for replicating all the segment events or the Mixpanel events, Google Analytics. So essentially what happens is mostly people come in because they see us as logging. And so that's the quickest and probably the pain that they had, which brought them to us, and they're happy. And then a week or two later, you talk to them and they've grown the number of data sets and you say, hey, so what have you been doing? And it's just, oh no, we're just sending like anything that whenever it happens, we're just sending it over. And it's super cool to see because they're just seeing value where maybe that data would have been lost in a queue or in Kafka or something and gone forever after it was processed. Now they have a history. They're learning from what's actually happening, which is valuable.
Yeah. And one thing that we're happy users of Axiom and Orb, and one thing that really stuck out to us, which is worth mentioning, is in addition to not having to sample, this idea of a wide event is really freeing from a logging perspective. I think that the fact that other providers penalize you for cardinality is really tough because it requires you to reason about what things am I going to care about, and also let me make sure that I'm conservative in the sort of tag explosion that might happen in the future.
Yeah,
and I
we've
think
all been there.
Exactly. One thing that's been great about Axiom is this idea that you can log something like the exact API path, right? Resource ID and all, and you don't have to think about the fact that this is going to be a big cardinality dimension. And instead, you can query over all of that. And I imagine that's a big reason why people can't use other tools, even if they wanted to, for something like this.
Yeah, the way we think about that is for you to send something to Axiom should require the minimal thought as possible, right? So it's schemaless, so there's nothing to manage in terms of telling us before you send us anything. High cardinality, or it just doesn't matter what the cardinality is essentially. So that's great. And then the idea of essentially overthinking like the shape of the event before you send it. Now, we have customers who accidentally put SQL queries as the key of the event, and that's not great. Right? But outside of that, overthinking it on the send side would just add more layers before you're actually doing something. And the idea is just not having to think about it too much. And then what we did instead was really focus hard on the query side. So the schema on read side, but also just the tooling you need to extract value from messy events. And so it's a combination of you may be sending highly structured data, but we're all human. And the reality is inside of that highly structured, there's probably something very unstructured. And like, how do you bring those worlds together in a flexible way?
Yeah. And it's a little bit counterintuitive because I think the temptation is on the technical side to think that there's some trade-off somewhere, right? If you're giving a lot of flexibility at right time, and maybe 10 years ago or something, the way you would have architected this or thought about this is, okay, you have to have some stream processing job that is constantly doing these roll-ups in stream.
Right.
And at the end of the day, you're not actually storing all of the data. You're just storing some rolled up pre-aggregated version of it. And what that meant was you had to, as you're saying, think about what you cared about in the data as you were sending it, or at least as you were configuring it, right? And so the temptation to me feels like, okay, if Axiom is giving me all of this ability to log whatever I want, change the schema over time, not pre-declare anything, I must be losing something in the query layer. But as it turns out, Axiom's query layer is both very expressive and also very fast, right? So where's that gap? How can you do both really fast and really flexible writes, but also really flexible reads? Is that just a function of how things have evolved over the last decade? Like, where's that coming from?
So I think that's a good point. The reality is like the gap is always closing between being able to be hyper flexible and or hyper efficient. And I think we're on the right side of that fence, because I think it's easier to go from a like being very flexible and then start to shave off the milliseconds until you get to where you want to be, versus starting from a very, like very strict schema heavy position and then trying to move across to being flexible. It's also that comes down to the query language and things like that. And so there's a bunch of stuff that's related. The reality is you wouldn't expect to use Axiom for something where you wanted the query to return within 100 milliseconds right now. The whole idea being that our architecture is meant for large scale with the minimal lift from somebody before they hit a query. There's no warehouses to create before you run a query. There's no sizing or anything like that. You just hit run query and the right thing happens. And what that means is the flexibility. You have to lose a few hundred milliseconds to make sure that all happens, versus what you could probably hyper optimize on something like ClickHouse if you knew everything up front. So I think you probably would have both depending on what your output is on the other side, right? But in Axiom's case, you'd be more in terms of, okay, for everything you care about between monitors, dashboards, and just ad hoc querying, everything is within a time frame where you're happy and you can move forward. But that said, there is some stuff that we're working on to make. And again, we see it as slightly different. We're like, how much of the data do you want under 100 milliseconds, right? Because maybe it's just the last hour or the last 30 days or something. And so there's things we can do to make that happen, essentially. So that's the more exciting things to land over the summer.
Yeah, that makes a lot of sense. And I think that's consistent with, I feel like, an industry-wide shift we're seeing on the technical side, which is you have products like WarpStream where they're questioning like what performance guarantee do you really need from your Kafka cluster versus the economics of it and maybe the simplicity of the architecture. And I think it's just not clear that we have made this trade-off in a super principled way. And so I imagine that a lot of people, they're not looking at their logs very often. They don't care about the difference between their dashboard loading and 10 millisecond queries versus 200. And
they all load
that's not the bottleneck anyways.
Second, right, exactly. They have the minimums 15 or 10 second refresh anyway. You don't know that it's happening realistically. But I think WarpStream's a great example because people will build up Kafka clusters. They'll do all the work around it, everything. And they're like, from in to out is 100 milliseconds or less. And it's why? Right? Like, these are all background analytics jobs. Like, what are you doing? And why does it take this team scaling this massive thing and essentially wealth transfer from VCs to AWS to make it happen? That doesn't make sense. So I think the problem that they're solving and the way they're solving it is absolutely right, because they're just saying there's a better architecture for that problem.
One thing you mentioned early on was this idea that no matter what use case the data is serving, the commonality is it's maybe semi-structured, but has some time column or some time series aspect to it.
Yeah.
Can you talk a little bit about what are the common technical things you need to solve when you're building a generic time series database? What are the different dimensions of technical challenge? And then maybe we can talk about how has Axiom started to attack each of those individually. But I'm just curious, what are the key kind of technical concerns?
So I think you'd always break it down. And in my head, I've always broken it down to like ingest, storage and such, right? And taking in that much data in in an efficient way where you don't know what's coming. So just because of the data set, you don't know 100% what the event is going to look like. So optimizations are very, let's say, you have to be an optimistic person, essentially, to write optimizations for something which you're not sure of. Robustness on the ingest pipeline, backup on the ingest pipeline, being able to get that written to something as quickly and efficiently as possible. So I think ingest is super important. And it's actually one of the key value where we found efficiency and Axiom's architecture, like the value that Axiom's architecture can provide is around ingest, actually. And it's not in, like the other ones are like technologies people recognize, but the sheer amount of work we did on ingest is one of the things. The other thing is, of course, storage. What do you need to store the data? Is it object store? Are you saying it's object store, but actually it requires some containers to be running or some VMs to be running to keep the data before it's available? What does that look like? And then finally, on the search side or query side, again, it's like, where are searches taking place, right? Like, how do you construct them? What is the planning looking like? What is distribution looking as for scale and things like that? So those would be the three key things that you would be looking at.
Yeah, and let's talk a little bit about each of those areas. So on the ingest side, I know that, as you mentioned, Axiom makes it really easy to ingest from different data sources, and again, the higher order bit being you shouldn't have to think a lot about restructuring the data, if at all about restructuring the data. Is the technical problem there like an N+1 problem where you're having to think about compatibility carefully, or is it more of a performance and durability once the data is piping in, that part of the ingestion step?
I think most of the time goes into performance and durability. Because it's just, that's people's events. You have to be like that. You're asking them to trust you with that. And so certain patterns emerge for a reason in terms of, let's say, the way Elastic would do ingest. You have separate VMs. Ingest comes in or a request comes in. It needs to be acknowledged by every VM. Recovery is completely banked on the fact that it is actually acknowledged. Because if something goes down, that's the only way, et cetera, et cetera. And those layers, the cross-node connectivity and networking, all of these things add noise and add cost to everything that's happening, even just compute cost. And so to rethink something like that, the middle stage of that was some data stores basically turned around and said, actually, it's not our problem. You have to run Kafka in front of us. And if you run Kafka in front of us, we will just be a consumer, and therefore Kafka will make beautiful batches and we will basically pull them in. And if we go wrong, it's on Kafka. We can go grab it from Kafka again. And so that was, let's say, 4 years ago or 2 years ago. And there's a bunch of data stores that still do that. And then our approach was like, you want to build in the Kafka-ness, but into something which isn't doing, it's coordination free, so it doesn't need constant acknowledgements from everywhere, but it makes it durable quicker. So you're not keeping things in memory in the same way that you would in some of the other solutions. And what guarantees are you getting from Kafka, and how does it, we don't want to replicate it, and that's WarpStream's job now, but what can we do for us to make it super easy to do? And so that's where the time and focus went.
Yeah, it sounds like there's a question there of how much responsibility do you take and absorb, and how much do you offload to a different thing sitting in front of your solution? But I imagine the more responsibility you offload, the less you get to be in control of the developer ergonomics too, right? If you're enforcing something, then now all of a sudden, in order to interact with Axiom, you have to do X, Y, and Z, which kind of undermines the whole not having to think about it, which I imagine is still a very important principle.
And honestly, coming back to not having to think about it, it's insane how many developers know the pricing pages of the tools that they use for logging and tracing and stuff, right? They know them off by heart. And one way that I describe it sometimes is there's decisions made at the keyboard before someone even types, which the organization or the company will never know is actually happening, because they're just like, I'm not even going to get into that. And so it's like, how do you make that lower? And then by adding these pieces or giving up responsibility into those, you are just, I think, you're putting the weight on the wrong side.
Okay, and so now let's move on to the second part of this, which is storage. Obviously, this is a key part of building a time series database. I don't believe, I think this is something you've talked publicly about, but the fact that you all use S3 as one of these storage layers. So
Right.
tell us a little bit about that storage architecture and maybe what trade-offs that implies for the product, or just like how much you've gotten out of, how much mileage you've gotten out of using something like S3.
Yeah, we did storage and search on hard mode. So yeah, storage was, I'll start with that. So it's only object store. So Axiom works on different clouds, but I use AWS Isms because that's where our
Sure.
cloud is essentially. So S3 and only S3. So we have one storage layer and that's it.
Mm,
And so
mm,
all of your data in Axiom, there's no such thing as like warm, cold, archived or warehouse data in Axiom. Everything is hot all the time. So you
yeah,
can basically do a query and check January 5 years ago or January now. It's all the same to Axiom.
yeah,
And so that's like that SSD type of between when we had hard
yeah.
drives and SSDs that way. But no, there are no SSDs in the process of Axiom essentially. Everything events are pulled into what we call blocks. And those blocks are essentially like these hyper optimized batches of events where we've almost pre-built some caches as well as
Hmm.
we've done various kinds of encodings, compression, and the format itself is ours as well. So this is what we've been like chipping away at for 4.5 years and making better and better since we decided to have this architecture. So we are sensitive enough to how good the S3 team are doing because
Yeah.
we can tell when things are not
Wow.
100%. And so it's one of those things where we were betting on that as the only way forward because it has to be. And this architecture exists in different
Yeah.
ways. But what we were betting on more than that was like, you can't take an off the shelf kind of format and have that as the way you actually put all
Hmm.
the events in and do that. And that's two reasons. One is the right side, where you want the highest compression that you can get and as much work done up front as possible, because on the query side, on the read side, we had pushed, and we'll talk about that, but we pushed all the querying to serverless functions. And so like you don't have this ability to have fast SSD reading to make something happen. You have to do it from there. So yeah, that storage layer is like critical. And the way we put that out has been, yeah, we're always on it. We're always
Yeah.
trying new things out and always trying to make it as efficient as possible.
And what this sounds to me similar to, and so I'm familiar with, for example, Druid, right? And Druid has this concept of a segment. And a segment, I think, sounds similar to what you're describing, which is this heavily maybe indexed and compacted version of events on something like S3. Is it true that you probably have some metadata store somewhere that's not S3, and then all the actual event data is mapped from that metadata store to some file in S3? Is that roughly right?
Yeah, so we have we call it the registry, but it's like a
Okay.
catalog essentially of where those blocks are, a little bit of what they represent and things. But like the way of tuning it is essentially what can you put in the registry versus into the headers of an
Yeah.
object in S3 versus the object itself. And
Interesting.
then you come into different clouds can do different things. So if you're on
Yeah.
Azure, you may be suffering for some other bits and pieces, but their blob service has some of the like some really incredible technology around the object store. And so
Hmm.
essentially they have indexed metadata on
Hmm.
things that like, what could you do there? Do you even need a registry and stuff? So there's a
Right.
ton of stuff we played around with and stuff until we came to that. Yeah.
Okay, that makes sense. And one of the things that I'm wondering is, you mentioned this idea of it's all the same tier,
Yeah.
meaning there's no quote unquote hot tier on SSD. How much does S3's innovation here matter in the sense of S3 introduces Express One Zone,
Mm,
and there's this kind of idea that you can shuffle around what S3 tier you're on without really changing the fundamental architecture, and
yeah.
maybe you pass some of that cost down to the customer if they need that, but really you don't have to change much as a product. You just have to tell S3, hey, after 30 days, move it away from Express One Zone. Is that realistic? Does that create too many kind of oddities around guarantees? Like specifically the Express One Zone, you are changing the guarantees on data durability. How do you think about that?
Yeah, so I think like in a perfect world, we would essentially have you'd only be using a zone like Express, and then we would just assume that AWS will move it over, whatever. I
Yeah.
think more what we do is essentially layer. And so it's
Mm.
more in terms of caching and things like that. I think that just comes down to, as you said, for us, what is it? Like 11 nines or 15 nines or
Yeah.
whatever S3
Yes.
is, plus the fact that you can do cross-region replication and things like that.
Mm-hmm.
So we set that up in the best possible way. And then every layer on top is essentially more in terms of it can exist or it can't exist. Doesn't really matter.
Yeah.
The main thing is that we know that the other side has been covered essentially. But
Yeah.
we have bring your own bucket, which means you can add your S3 to Axiom essentially, and we can read and write from your own VP. But we abuse the crap out of that all the time, and we'll be connecting it over to Minio, we'll be connected over to some of these new object stores, and we're just trying things out to see what are those guarantees. Are they better? Are they faster? Could they be integrated into Axiom's processing? And like what benefits could a customer get out of that? And then I think that's what I'm saying more towards the summer side is some of this shouldn't be inside of Axiom with us making the decision. I think some of this we should be exposing to the users and saying, you're building on top of us, so you know the right thing that you want to get done. Click this button and it will happen, essentially.
Yeah, that's really fascinating. It sounds like directionally moving towards a little bit more of a plug and play model where you're really trying to isolate, here's our core technical competency, but hey, you as the consumer or the user can make the right technical trade-offs surrounding that. Okay, let's talk about query, which is, I imagine, where a lot of the fun stuff is. Yeah, so I don't want to undersell this point because I find it very impressive. Axiom can query hundreds of millions of rows in a matter of, maybe it's not single-digit milliseconds, but tens of or hundreds of milliseconds, so really quite fast. Yeah, how have you built up to that? Are there any significant unlocks that you realized over time that really helps get to where you are now?
Yeah, we didn't release our public cloud until S3 and Lambda were talking to each other in a good way, basically. Yeah, so we decided early on that if we got the data in, we got it stored, but then you still needed to run VMs to query it. That would be a failure, essentially. We had really good experience around, or bad experience, whichever way. We have deep experience around scaling Elastic and things like that. We knew that wasn't the way either. And so we essentially came up and said, we're going to make serverless query work. And that means when you press a button, whatever's the right amount of resources to use, we will create them, use them, drop them, and you'll get the answer. And so that required a few kind of things. All our data is on S3, serverless queries Lambda. So Lambda S3 connectivity, that interconnect had to be at a level where we could pull enough, as you say, if it hundreds of millions of rows, billions of rows, you could be scanning high terabytes of data or more. And now these days, people, they're setting it up in, okay, go scan a petabyte, right?
Yeah.
Those interconnects needs to be great. We definitely were building this before they were great. And so we know what it looks like on the other side, but they are pretty good now. And so that was one of the things. The other side was like that query planning and execution. The reality is if you're querying a month or a year, it's not ON, right? Or O1 is going up. It's going to be more like O log N because it's all about the essentially being able to do the merge of all the results that come through, essentially, which can take effort. So it was like, okay, how do you make that better? How do you make sure that someone just wanting to do a year's and like quick, hey, what was the count for the year? And they just set it on the thing and now they go, how do you make that better? And so essentially we were building this out. And then what we realized was, like, yes, there's work you do on the query side. Our query language APL lets you do all sorts of stuff like running regex, parsing, equal, lots of different things that you can do. But actually, the work you do up front is going to basically set off everything that happens afterwards. So then it came back to the block. And so essentially, like that block format needed to do the right thing for this kind of event queries where you're just streaming out the raw events or parts of the raw events, or analytical queries where you're running 5 aggregations at once and you want to just peek into the bytes you need to peek into to get that data and move on, and then obviously build the caches and things like that. So yeah, I love that that's how it works. We everything we built, flows, everything work on essentially what you could be calling super efficient batch processing, right? That's actually what's happening. But it's just, there was those stumbling blocks initially where we were trying to go faster than AWS were ready. Then we waited. But now it's like when they make performance improvements, we can see them, which is amazing. As they make Lambda, you can choose the sizes, you do whatever. Axiom's doing that all the time. It's choosing, right, do you need a little bitty Lambda because you just need this much memory? Or shall we go give you the heavy ones because you need to do X, Y, Z? And no one clicking that button has any idea of that's what's happening. And I love that because the entire idea that you need to know the kind of how large your query will be is ridiculous to me.
Yeah, that's really interesting. Tell me if I'm thinking about this the wrong way, but there are certain tools that have done a lot of optimization at the storage block segment, whatever you want to call it, layer, which it sounds like Axiom has. And then there's certain tools like DuckDB or even ClickHouse that just have concentrated on an extremely performant query engine. Let's say once the data's in memory, right? Like they can just do these queries the fastest. What I'm hearing from you is like, for the Axiom use case, the former matters a lot more than the latter. Is that right? Or have you also, and do you intend to put a lot of work into the actual query engine, even if you've optimized the storage layer as much as possible? Like how do you think about those two different parts of the problem?
So I think you just find us on that journey at the moment because it's now we focus much more on the query side than we traditionally did. Traditionally, we were just wringing that block for everything we could get out of it. And even today, we'll still try things out and it's easy for us to do that. But mostly now we do focus on the query planning and execution. People want joins, they want subqueries, lookups, all these things. And so for that to be delivered, and you do need to spend more time on the execution layer. So that's where we are now. But I think that block format is something which is like, it does, we do tune it and change it, but definitely feel like we've been touching it less now than we had done in previous years.
Got it. Yeah, and actually, maybe let's talk about what is not quite the final piece, but one of the edges of this, which is what you mentioned as your query language. So most companies, I feel like, think about one surface of these problems, right? Like the storage or the query execution or even the ingest. But you all have also decided to build your own query language. And the question is why and like what benefits has this brought you, and just guide us through that as an additional piece of, I think, innovation that you all have been leading.
Yeah, definitely times where I think that why the hell did we do this? But there is a reason. There is a reason. So essentially, our query language, APL, is actually, it's a super subset of Microsoft's KQL, which is the Kusto query language. So Kusto, for those who don't know it, is this kind of world store that Microsoft built in Azure, and it can do all sorts of different things with events, and including you can build graphs out of them, geo, all these different things. And they were looking for a query language, and essentially Splunk was that first pipelined query language, SPL, and really nice to use, etc., but dated. And so KQL is like a modernized version of SPL. And when we were like in the market for a query language, we knew it wouldn't be SQL. And there's reasons for that in terms of just when you don't have a schema, when you want to do tons of text things, run functions, whatever, SQL just doesn't feel right. But we were trying not to completely build a brand new language. So we looked at the KQL spec, and then APL is essentially our implementation where we've picked and we've chosen what makes sense. And then we've just added all the stuff Axiom can do that Kusto can't, for instance, and dropped the stuff that Kusto's kind of thing. But for us, it was pipelining is great. When I think of event streams, I think of things moving from left to right, and I'm picking and choosing from them, and they drop to the next level, and then I do it again, or I aggregate them, whatever. That is literally what you would write into APL to make it happen. So I love that idea. The other side of it was we can do multiple aggregations at once and things like that. And so we expanded it with support for that, more options, more functions, and all of those things that you would care about. But the real thing was we knew we would get into the processing part of this kind of event problem that exists in every company. And so as we graduated to the processing side with flows and things, we actually wanted to add more operators, more verbs for the thing that you're actually doing. And so we wanted an extension point for, okay, if tomorrow you're like running functions, we want to add function calling, we want to add this, that, whatever. And so I think up until now, we just tried to make it solid as possible and cover as many bases as possible for the needs. And again, now we're at this cool point where we're now extending it, and it becomes a language where when you read the query, you're essentially just saying English in exactly the way that the query processor is going to process it. And I think that's really valuable.
Yeah. This sounds like a lot to be working on at the same time. So I'm curious, like, how are you thinking about where you push the boundaries the most in what sequence? We just talked about these four very heavy things: ingest, storage, query, and then the query language itself. What is your mental model or framework for that?
It is moving left to right in a weird way. So ingest and storage was like the most important things that we had to nail, and we did that initially and early. Then storage and querying, so the blocks and how we do querying was the next thing. And getting query up to a point where as these complexities grow, because the organization, the size of the organizations grow and what they want to get done is different, we could match them and make sure that everything they want is always just on the horizon of what we do. And so rather than worry too much about the kind of bread and butter parts of querying, now it really is about, okay, being able to execute something and make sure that we can join it with two other things and or union or whatever it is and make sure it comes down. So I think that's where we're at now. Flows becomes the next kind of thing where you see a peak of it very soon. And then that peak will have a very specific use case, which we will nail first. But then you'll see that becoming what we want it to become in terms of almost like a heartbeat for events inside your org, and allowing you to not have to rely on these kind of off-the-shelf tech, which wasn't really built for this problem, but absolutely solved our issue, no doubt about it. But now maybe people who've been obsessing about this can give you something which gets you from A to B much, much quicker. And so I think obviously the company grows, people grow, whatever, but generally we're moving more to the middle and the right-hand side of things now, where it's let's make query exceptional. Then let's get flows out there, make sure that people can get real value on day one, but then let's make flows exceptional. And then what you'll see Axiom be is like a very, I think, a super unique place for what you do with events. And it doesn't matter whether you're a dev and you just want to know what's happening with traces or logs, or whether you're actually connecting it to your product, like so many startups have already done, or whether you're just like, actually, what the hell happens with our support cases, right? What can I do with that to make it whatever? And you can just use Axiom in a more flexible way.
Yeah. So that's related to the last question I wanted to ask you. And I feel like you've talked about lots of things here, but what is it that you're most excited about? It sounds like there's the summer launch coming up. It sounds like this is both on the technical innovation as well as some of these partnership angles. Yeah. Which part are you most looking forward to?
Nothing actually makes sense if we couldn't put it into everyone's hands. And so the efficiency of Axiom is still the most exciting thing. And the fact that it's getting more efficient while doing more things is crazy to me. But like it's the architecture is coming together in an awesome way. So absolutely crazy excited about the fact that very soon you'll be able to run pieces of code against Axiom on an event pipeline, right? Or be able to connect it back out into not just something like S3 or for export or Splunk or whatever, but also other tooling which you're using. That silo busting that you can do, because you can put Axiom in front of the tool that you're already using and actually have Axiom have months or years worth of data and that tool have 30 days. That's super cool. And I think it's like going to be awesome. But the reality of it is all of that would be great. People do it, but it's only the top companies with the deepest pockets that can do it. And so the exciting thing is we can bring it to everyone, and that's super cool. And Axiom just continues to get like more and more efficient, which is really cool as well. We still don't qualify for any of the AWS credits, which is insane. Or like discounts. It's wild.
Wow. Hey, I appreciate that. And I love the continued focus on the customer experience as the kind of core thing that makes Axiom great. And yeah, thank you for taking the time. This was a lot of fun, and I appreciate you walking me through that technical journey.
Yeah, not at all. Thanks for having me on. It's cool to talk about it.
Of course. Thanks, Neil.
Cheers.